מי שלא מכיר, יופי, מעולה, תודה. אז למי שלא מכיר, הקים קהילות ואיגודים טכנולוגיים בתחומי ה-Cloud ו-AI, והיום הוא המנכ"ל של האיגוד הישראלי לטכנולוגיית שפת אנוש. וככה אפשר... תודה רבה רבה על העזרה בארגון ובכלל על ה...
אוקיי, שומעים אותי? שאני שומעת?
שומעים היטב.
כן, שומעים, יופי. אז קודם כל, שלום לכולם ותודה לכל מי שהצטרף למפגש הזה, ותודה כמובן לשני וקהילת ה-NLP פה בארץ. אנחנו כמובן חלק מהקהילה, ומאוד חשוב לנו לשתף את כל העשייה המקצועית שנעשתה בשנה האחרונה, תוך כדי הקורונה ולמרות הקורונה, הצלחנו להגיע להישגים מאוד יפים, ואנחנו רוצים לשתף היום את כל ההישגים של האיגוד הישראלי לטכנולוגיות שפת אנוש עם כל הקהילה. ההרצאה שלי תהיה בעברית, אבל כל ההרצאות אחר כך יהיו באנגלית. אז אני אתן רק כמה דקות עם כמה סליידים של להסביר בכלל לקהילה מה זה האיגוד הישראלי לטכנולוגיות שפת אנוש, ולאחר מכן ניתן את הבמה לנועם, שהוא המנהל המקצועי שלנו בפרויקט ה-NLP שלנו, והוא ינהל את האג'נדה ואת המרצים אחר כך. אז אני אתחיל בכמה סליידס להסבר כללי. אז קודם כל, האיגוד הישראלי לטכנולוגיות שפת אנוש, אנחנו הקמנו אותו בספטמבר 2020, בשיא הקורונה, ולא ידענו תוך כמה זמן נצליח להתארגן, כי גם זה לוקח זמן מבחינה ביורוקרטית לעשות כל ההקמה עם רשם העמותות ותקציבים וכו', אבל למרות הכל עמדנו בכל האתגרים, ובתחילת 2021 למעשה יצאנו לדרך ברמה התקציבית של הפרויקט, ובזמן הקצר הזה הצלחנו להגיע להרבה הישגים. אז קודם כל, אני רוצה להגיד כמה תודות. קודם כל, תודה גדולה לרשות החדשנות וישראל דיגיטלית, אחד לאביב זאבי, יעל רוזנברג, מוטי בנדו ונועם מילוביץ', שעוזרים לנו בפרויקט עצמו, גם בליווי וגם בתקציבים, ובלעדיהם כמובן לא היינו יכולים לבצע את התקציב הזה, בלי העזרה התקציבית של המימון המשלים. וכמובן תודה לכל חברי האיגוד שהצטרפו עד היום, ואתם רואים פה את כל החברות, אני אתחיל לקרוא את כולם בגלל הזמן, אבל יש לנו מחברות גדולות ומובילות בינלאומיות ועד לסטארט-אפים קטנים, וכמובן כל חברה מוזמנת להצטרף ל-20 החברות הקיימות, וליהנות מהשירותים והקורפוסים המתויגים שאנחנו מספקים. אז קודם כל אני אתחיל מהנקודה מה הצורך, בכלל בשביל מה הקמנו את האיגוד הישראלי לטכנולוגיות שפת אנוש. הצורך הראשון זה שיפור הבנת השפה העברית והערבית במערכות ממוחשבות, כדי שנוכל לתת שירותים איכותיים יותר בתעשייה, בממשלה, באקדמיה, שלא נפגר אחרי מדינות אחרות שיש להן שפות פופולריות. כמו שאתם יודעים, שפות פופולריות כמו אנגלית, השקיעו בהן הרבה יותר משאבים במהלך ההיסטוריה, בגלל שיש איזה פוטנציאל עסקי הרבה יותר גדול, ובנוסף לזה, בנוסף לכל הצעות, גם השפות השמיות הן יותר קשות ברמה האלגוריתמית, ולכן שתי הסיבות האלה יצרו פער איכותי בינינו לבין האנגלית, ויש לנו אינטרס לאומי שלא נפגר ביכולת שלנו לתת שירותים מבוססי שפה עברית וגם ערבית במדינת ישראל. יש צורך בהקמה של תשתית ליצירה ושיתוף קורפוסים מתויגים עם כמות גדולה של משפטים למחקר ופיתוח, שיתוף במשאבים כדי להתגבר על קשר שוק שבו חברה בודדת לא יכולה להתמודד עם השקעה נדרשת, כמו שאתם יודעים, חברה קטנה כמו חברת סטארט-אפ לא יכולה להקים תשתית של קורפוסים מתויגים, זו השקעה מאוד גדולה, וכדי לאפשר גם לחברות שאין להם תקציבי ענק להתמודד עם האתגרים האלה, הפרויקט הזה בהחלט מאפשר את זה לכל אותם חברות שאין להם את המשאבים האלה, וכמובן שיפור כושר התחרות והייצוא של התעשייה בתחום של AI ו-NLP, במיוחד מול השפה הערבית, עם מערכות השלום והאמירויות, יש היום פוטנציאל ייצוא לכל השוק של הערבית, וחיזוק שיתוף הפעולה בין התעשייה, האקדמיה, הממשלה, מערכת הביטחון, וכל מה שקשור לתחום של אפליקציות שפת אנוש. תוכנית היא ל3 שנים פלוס אופציה ל3 שנים.
מה
אתה עושה? אני מבקש בבקשה לעשות מיוט.
תקלח אותה, אנחנו נקלח את הוידאו.
טוב.
מי שלא עשה מיוט, שיעשה מיוט. אוקיי. התוכנית עצמה היא ל3 שנים, פלוס אופציה לעוד 3 שנים, זה מבחינת המימון המשלים, האופציונלי מהמדינה, כאשר 34% מהתקציב מגיע מחברי האיגוד, ו66% מהתקציב מגיע מהרשות לחדשנות. עכשיו פה בעצם אנחנו מקבלים סבסוד מאוד רציני עבור הפרויקט הזה. מה הם בעצם הבעיות שאנחנו פותרים, שהאיגוד פותר? אחד, זה הבעיה המרכזית של מחסור בקורפוסים מתויגים, מגוונים ואיכותיים, לימוד מודלים. אין היום מספיק קורפוסים מתויגים, איכותיים ומגוונים, והיעד שלנו ב3 שנים להגיע ל50,000 משפטים, שמתויגים גם מורפולוגי, גם קלילות וגם ישויות, זה מתבצע על ידי בלשנים איכותיים, ולהגיע בעצם לגולד סטנדרט, שיאפשר את כל אותו שיפור איכותי של המודלים והאפליקציות הנדרשות. כיום אנחנו כבר מגיעים, נועם, כבר הגענו ל15,000 משפטים מתויגים, וקורפוסים נוספים שתכף נתאר אותם, ונועם והרצאות אחרות יספרו איך אנחנו עושים את זה. הבעיה הנוספת זה מחסור בכמות גדולה של טקסטים, לימוד מודלים בתחום של ה-unsupervised, ובזכות ההסכמים שיש לנו ספקי טקסטים גדולים, במיוחד מתחום העיתונות ומקורות ממשלתיים, אנחנו יכולים היום לספק כמויות עצומות של טקסטים, גם לנושא של מודלים של unsupervised. נושא של הורדת עלויות התיוג, אנחנו זקוקים ליכולות תיוג אוטומטי, כדי שנוכל לקבל כמויות גדולות של טקסטים ולתייג אותם במהירות, תוך חיסכון בזמן ועלויות, ולמעשה בעברית כבר יש לנו היום תשתית שהקמנו שמאפשרת תיוג של מורפולוגי וקלויות, ואנחנו עכשיו מסיימים את הנושא של ישויות, ואותו דבר גם השנה נבנה לערבית. ופיתוח יכולות נדרשות בקוד פתוח, כמו התממה או השחרה של טקסטים. כמו שאתם יודעים, יש הרבה סקטורים בתעשייה, כמו בתחום הבריאות, המשפטים, הביטחון וכולי, שלפני שהם יכולים למסור טקסטים, הם חייבים להוציא החוצה את כל המידע הפרטי, או מידע אחר שאסור למסור אותו, ואין היום איזושהי יכולת גנרית טובה בתעשייה, ואנחנו הולכים לפתח יכולת כזאת. אז כל דבר שנדרש מבחינת התעשייה לשיפור היכולות של מחקר בתחום ה-NLP, אנחנו גם עושים בתחום של קוד פתוח. אז מהם ההישגים הראשונים שלנו בשנה הראשונה? קודם כל, יש לנו 20 חברות, זה לא משהו שאפשר להגיד שזה הישג קטן, זה הישג די גדול, לאסוף 20 חברות מהגדולות ביותר בעולם ועד הסטארט-אפים הקטנים, וזה מה שאפשר לנו גם ליצור את הגרעין התקציבי לפרויקט הזה, שבלעדיו זה לא היה מתקיים. גייסנו צוות מקצועי מוביל ברמה בינלאומית שהיום תשמעו אותו, הוא מציג את העשייה. עשינו הסכמים עם ספקי תכנים ממקורות רבים ומגוונים, שמאפשרים לנו לעשות את כל הפרויקט הזה, אם מבחינת תיוג ידני או תיוג אוטומטי, וההישג פה בגדול הוא גם שאנחנו הצלחנו לקבל הסכמה שלא רק האיגוד עצמו יקבל את הזכות לגשת לתכנים, אלא גם חברי האיגוד עצמם, מה שהיה בעייתי לפני הקמת האיגוד, כי אף אחד לא רצה לתת גישה לחברה פרטית ספציפית. דבר נוסף זה שהקמנו תשתית ענן לשירותי תיוג אוטומטי וגישה לקורפוסים, שהוא מבוסס קוד פתוח ותקן UD 2.8, שזה התקן האחרון של UD, וסיפקנו לחברים קורפוסים שיתארו אותם במסגרת ההרצאות הבאות, כמו קורפוס שמתויג ידנית מורפולוגית תלויות של יותר מ10,000, היום זה עומד כבר על 15,000 משפטים, והקורפוס דו-לשוני עברית ערבית שואליין, 200,000 משפטים, ומאות שעות של הקלטות מתומללות מהכנסת. זהו, אז אתם כמובן מוזמנים להצטרף. יש פה את האימייל שזה info@IAHLT.org. כל מי שמעוניין בעוד מידע או הצטרפות, מוזמן לכתוב לנו, ונשמח להיות בקשר. אז אני אעביר את השרביט לנועם, שינהל את האג'נדה, ובהצלחה, נועם.
זה בשיר עדיין, נכון?
כן, אני אעשה סטופ שייר, בבקשה.
טוב, שלום לכולם, hello everyone. אני אדבר באנגלית.
מה? בטח.
תשים על מיוט בחייה. תודה.
זהו, במיוט. אני אהיה השוטר פה, כן.
בסדר. אני הולך לדבר באנגלית כי יש פה חברים שלא מדברים עברית, אני לא יכול להגיד שמדברים רק אנגלית, כאלה בטוח אין פה. So I'm switching to English. Okay, so thank you everyone for joining us today. We ended barely with our last breath. The last year, it was very challenging in terms of Corona. You can see it in my title, but also in terms of speeding up towards deadlines and also planning the year ahead. And dealing really with a lot of professional and sometimes human, I would say, challenges in terms of how to manage this project. The talk we are going to give you today is not only about what we did, and what we are going to do is kind of an agenda in general about the role of linguistics in NLP as of today. So I'm not going to share screen as yet, okay? So you'll have to bear with me and, with my face for a while, and then I'm giving the floor to Amir, and then I will share my screen with presentation. Thanks, Nathaniel. The idea is that in the age of deep neural networks is that many people became a bit skeptic about the role of linguistic knowledge. Having said that, if you just look at how many linguists are recruited for the big companies, you can see that it does play a role, and the question is what role? If you look at machine translation, for example, many people say we don't need linguists there. What they don't take into account that there is a lot of expert knowledge already embedded in parallel corpora, and obviously, without this human knowledge, machine would not be able to learn, not well at least. So I think that would be an example. And when it comes to morphology and syntax and semantics and rhetoric, then we don't have such a byproduct of someone just doing translation for whatever reason, and then the machine can take the example and learn from them. So the first presentation is going to be by Amir Zeldes, and it's going to be about English because we want you to mind the gap of where we are at Hebrew and English and Hebrew and what can be done, because in English, obviously, there are more resources. So he can give you some idea of part of the projects he was involved in, to the extent of how we can do linguistics for NLP nowadays. And then I will describe the process we are, how we actually do this kind of factory of annotating corpora and how we go about it. Then Nick will talk about the validation process and about some pipeline of QA is building. In the meantime, it's somewhat deterministic or semi-deterministic, and we will only be able to do it a more probabilistic approach once the data is really integrated. And I'll talk about it briefly, and then Nick will present more. And finally, we want to collect large amounts of data, but we also for unsupervised learning, but the question is how to sample them and how to process them. And that's going to be the talk of Yousef Tannous. So I will give the floor to Amir, and thank you. You can basically share screen, I think.
Thanks, Noam. Thanks, everyone, for introducing. I've been asked to speak in English, so I'll do that as well. Can everyone hear me?
Yes.
Excellent, and I will share my screen.
We hear you.
Can you see my screen? Can everyone see? Okay, great.
Yes.
Thank you. Well, thanks for inviting me. I completely agree with what Noam has said, and I'd like to echo that the role of linguistics in contemporary natural language processing is actually very central. The most important contribution being that linguists decide what systems should emulate. So a lot of our systems, of course, are trained on some sort of training data, and all of that is determined by experts who know the domain and know the tasks and know what we want to do, and of course in error analysis and in tailored applications as well. So as Noam already said, I'll be talking today about English primarily because a lot of kinds of data we don't have for Hebrew right now. But I'd like to motivate a little bit why we want this kind of data in 2022, especially as we are using more and more plain text-based, transformer-based end-to-end approaches. I'd like to start by thanking the IAHLT team led by Amir Zeldes and everybody else who's been working on the data sets that are coming up. And of course, also the National Digital Office and the Israel Innovation Authority. And I'd like to give a shout out to my lab members who are responsible for a lot of the research I'll be presenting on English. If you want to see their work, check out our website and our GitHub. So we've been talking a lot about building annotated data sets for Hebrew, the next generation of data sets like these. And for those of you who don't look at data like this too often, here's an example sentence with some annotation. And it has a syntactic annotation graph with the relationships between the words, telling you what's the subject, what's the object. You can extract various interesting things from this. You can extract that there's some sort of central predicate which has certain participants. In this case, it's about some advertisement, including an appearance of some person, Winona Ryder, and perhaps also indicating where things are mentioned in the sentence, such as the person span for Winona Ryder, and perhaps even some sort of linking to a table of authorities, in this case, the Wikipedia entry or the title of the Wikipedia article about this person. This is what I'd call a highly structured representation of language data, with syntactic, semantic, and perhaps even pragmatic aspects of text understanding being represented. And I'd like to motivate in this talk why we need these kinds of resources in the age of BERT. So because we have been working increasingly with unlabeled data to do a variety of things that previously required data, people start developing the impression that maybe you don't need these kinds of annotations at all. And I'd like to make very clear that that is not the case, primarily using examples from English, but of course the motivation applies cross-linguistically. So, a lot of current papers, if you look at state-of-the-art scores on a variety of tasks, be it co-reference resolution, named entity recognition, nested or non-named entity recognition, basically get top scores just by using a transformer pre-trained on large amounts of plain text data in order to map the text to some sort of target label scheme. And the reason why this works is because the transformer has seen a lot of different environments for words in the past. And a lot of the different distinctions that we make using explicit annotation schemes are already encoded in the varying probabilities of surrounding text for words. A really attractive feature of this approach is that it's simple. It's also to a certain degree extensible because if you have new tasks, all you need to do is plug in a new training corpus, you fine tune on it, and you get reasonably good results. The biggest advantage is that no feature engineering is involved, which means you don't have to invest hard work engineering the features. You don't have to choose difficult choices between features, and you can get results relatively quickly. At the same time, after the initial euphoric neural tsunami that started in, I want to say 2015, people started noticing problems with this approach. In a recent EMNLP keynote talk, Ido Dagan mentioned that BERT has a glass ceiling. And I think this has become evident to people working in the day-to-day with transformer-based models. One of the things that are quite surprising in working with these models is that although they achieve initially very impressive scores, they degrade out of domain in a way that seems drastic. So not the degradation that people were used to from expectation maximization and even lexicalized approaches themselves, but really some more extreme degradations, which are a little bit surprising given the quality that you expect from these approaches. And then you get users saying, why is this hallucinating that? Why is this completely implausible result? I could have told you using some stupid rule-based approach that that's impossible. Things like that. In addition to degradation out of domain, there are a lot of use cases where the E2E approach, and maybe I should explain a little bit better what I mean by that. I mean end-to-end. So the end-to-end approach using just plain text mapping to labels. In some cases, this approach is simply not feasible because we don't have the labeled data that you would need for it. And creating the labeled data is either too expensive or impractical because the data would become out of date very, very quickly. So you could learn to map data like this immediately for some topic you're interested in today. But if you wanted to use this approach next month, you would have to relabel another data set. For all of these reasons, I'll try to motivate today that out-of-the-box linguistically motivated NLP, including using transformers, is more ideal for many practical scenarios. So I guess my first job is to convince you that there's a problem with end-to-end approaches. Here's an example from a paper authored by a student of mine, Yilun Zhu, in cooperation with myself and Samir Pradhan, working on coreference resolution out of domain. We looked at the state-of-the-art coreference resolution technology using SpanBERT, which is a, I'd like to say, obscenely large language model. It's kind of crazy. It takes, I don't know, over 32 gigabytes of GPU RAM to train. And you can get scores in the low 80s at this point for coreference resolution on the OntoNotes benchmark, which is a corpus with about 1.6 million words annotated for coreference in English. So again, actually, this entire thing wouldn't work without labeled data at all. And of course, we have no coreference resolution data for Hebrew. So this is science fiction for Hebrew. But what's really surprising about this is the degradation. So you can get low 80s on OntoNotes, which is pretty satisfactory performance if you look at the data and the kind of errors you see there. But the average degradation out of domain is not 5 points and it's not 10 points. It's 15 points on average. And we tested this on 12 different out of domain genres. One of the most shocking results was that on news, actual news, which is a huge component of OntoNotes, which contains the Wall Street Journal corpus, there's a degradation of 19 points. That's about a quarter of the score. If you're wondering what's so difficult about this task or how it's possible to have these degradations, consider the example at the top right. This might be illuminating if you've never seen coreference resolution before. This is actually not conversational data, despite the I and you in the example. It's actually from a Reddit forum discussion. So somebody's complaining about his experience working as a customer service representative. So he says, the customer says, I know you have it right in front of you. Me, colon, I can only see the last 4 digits of your credit card for security purposes. Customer, colon, blah, 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 blah. So you see, this is quite difficult because the system needs to understand the different me's and you's. The system needs to understand that customer is the same person as I in some sentence. It's quite tricky. And unsurprisingly, these kinds of environments have never shown up before in the news domain or in other domains covered in OntoNotes, and the system becomes confused. So yes, the task is extremely challenging. How is it possible to solve this task to an 80-point solution on the test set of OntoNotes? The answer is because the test set in OntoNotes is shuffled out of the same population as the training data. And this leads to what we call covert overfitting. It's not standard overfitting because in normal overfitting, you would expect the test data to degrade. The system has never seen the test data. So if it performs well on test data, then it performs well on so-called unseen data. But the data isn't really unseen because it's from 1990s Wall Street Journal. And that also answers the other question you might have, which is how is it possible for it to degrade 19 points on the news? It knows news. Yes, it knows news, but it doesn't know Google, it doesn't know smartphones, it doesn't know social media, it doesn't know any of that stuff. And we have very much the same situation with Hebrew where training data is out of date. If that doesn't convince you, let me move on to another example. This is entity linking or Wikification, so identifying Wikipedia entries for entities mentioned in text. In this paper, my student Jessica Lin and I looked at a state-of-the-art end-to-end system trained on the largest data set available for the task. And it scores not so great. So if you want, the first takeaway from this slide is that entity linking doesn't work very well out of domain. You get 25.9 F score, so not so great. The more surprising lesson from this task, which is a difficult task, it's basically the task that you see at the top right here. In the example, Tulsa Transit provides bus service. So Wikipedia actually has an entry for Metropolitan Tulsa Transit Authority, and it also has an article for Tulsa, Oklahoma. The surprising thing that we found in this paper is that trying to construct a baseline, if you just take a state-of-the-art neural parser, a constituent parser, we took Marini et al. 2020, which does very, very well on PennTreeBank. It scores 95% on PennTreeBank, which is Wall Street Journal and from the 1990s. And then you take all of the predicted phrases from this constituent parser, and if they are proper noun phrases, you assume that if there's a Wikipedia article with the same title as that phrase, then you should link to that Wikipedia article. Sounds pretty reasonable, right? So if the parser found the phrase George Bush and there's an article George Bush in Wikipedia, it links it. That's it. That's the entire thing that the baseline does. And guess what? It does a little bit better than the end-to-end system, not by a lot. And I won't say it's great. It does badly as well. But we should be a little bit shocked. in, I guess, now 2022, that end-to-end neural systems can't outperform a constituent parser doing string lookup in Wikipedia. Again, this is not to say that end-to-end approaches are stupid or don't understand their training data. They understand their training data very well, but they overfit their training data. If you try to think back to your university stats class that you took, remember when the instructor said not to assume anything that's not rationally correlated with your outcome variable? Well, if you assume a lot of things, you'll get spurious correlations, and no amount of regularization will allow you to predict things that are not present in the training data. So why does it work to take phrases? Well, it's pretty simple, because most mentions of things in text tend to be noun phrases. Parsers are very good at recognizing noun phrases in a domain-independent way, and things that have the same string as a Wikipedia article are probably that Wikipedia article. Could we do better than this? Could we filter this for spurious correlations, strings that tend to not be Wikipedia articles? I'm sure we could. The point is that end-to-end is not the whole story. So at this point, I'd like to argue that annotating is something like NLP's fundamental science, a little bit like basic measurements in chemistry or physics or astronomy. It's a fact that most mentions of things in text correspond to noun phrases. It's also a fact that parsers are specialized for this purpose. They're very good out of the box at recognizing noun phrases in a domain general way. I'd like to give you a little bit of a counterexample of what happens when you don't respect linguistic conventions and consequently can't use this kind of logic. Those of you who have worked on biomedical NLP might be familiar with the Genia corpus. It has text like this box at the bottom right here. A defective NF-Chi-B site was completely inactive in EBV transformed B cells, and there's various categories here. So NF-Chi-B site is the category DNA, and Chi-B is also the category DNA, and NF-Chi-B is a protein. I'm sorry if I'm reading this wrong. I'm not a domain expert. And you could add whatever you want. You could decide that EBV is a disease, and I want to label that as a disease, and so on. Could BERT learn this? Yes, absolutely. BERT can learn this, especially if you're being consistent. I'll add as an aside that if you're being inconsistent in what you're labeling as a span, then no amount of BERTing will save you from this. At the same time, I'd like to point out a little linguistic inconsistency. So NF-Chi-B site is not a noun phrase. The noun phrase here is a defective NF-Chi-B site, and the article a is not included. The Genia corpus isn't totally consistent in this. Sometimes you'll get the, sometimes you'll get a, sometimes they'll be included, and sometimes they won't. This leads to inconsistent results in general. So high quality QA, quality assurance, is very, very important. But at the same time, even if you were being perfectly consistent in how you label this kind of data, if you ignore the linguistically meaningful units here, you can't use the approach that we did in the previous slide. You can't use parsers because these things are not actually natural noun phrases. Does that matter for Genia? If you're using an E2E approach and only learning on the Genia corpus, maybe it doesn't matter. But it means that you can't pull resources. It means that you've worked in an idiosyncratic way. You can't use pre-training. You can't use multitask learning on a corpus that has different phrase boundary definitions. And ultimately, this will lead to poor out-of-domain generalization. So how you annotate is really, really important. I'll move on to my second point, which is not all situations lend themselves to the E2E paradigm. Here are just two examples from last year. Rao and Taboada, Gender Bias in the News, Frontiers in AI. Here's a little quote out of the paper. We first identify quotations. So they were trying to look at whether or not news sources quote women as often as they do men. Unsurprisingly, they don't. And also whether or not women or men are discussed in a certain quote. So they first identify quotes, reported speech, whether direct or indirect speech was used, associate a speaker using co-reference resolution, and finally look up the gender of the speaker. Thanks to this NLP pipeline, we obtain gender statistics. Could you learn this E2E? Well, I suppose you could, but how would you do it? You would need to label a ton of newspaper data for whether or not the speaker was female or male, for anybody mentioned in a quotation, whether they were female or male, and after you did this for 10,000 sentences, you get good results. Sure, but can you do that? So this is an ad hoc question that they were able to answer adequately using out-of-the-box NLP frameworks. They also tried looking at words used to discuss men and women and found that using dependency diagrams was much more useful than collocations or n-gram frequencies. For those of you who don't know what that is, basically looking at surface sequences of words versus looking at things like a verb and its object as predicted by a parser. Similar example, paper by Ines Rebine and colleagues at EMNLP last year, recognizing free electoral coalition signals in the news. trying to figure out which news articles predict what coalition will actually be assembled in politics. So their examples are challenging because it requires speaker attribution, reference resolution, polarity shifting. The task requires a considerable portion of world knowledge. Do we think that Bert knows about this? Do we think that the Wall Street Journal corpus from 30 years ago tells us about this? It probably does not. Here are just some examples of results from the Rao and Taboada paper, which should lend some credence to the usefulness of what they discovered. They found that arts and entertainment articles were much more likely to mention quotes by women, as well as healthcare and medical research. In US politics, it was male-dominated across all months between October 2018 and September 2020. If you look at the dependency diagrams, you'll also see that using dependencies was quite helpful in understanding the discussion of, say, male and female speech around, in this case, it's finance. So the male side has rate raise, low hit, income report, point lose, growth slow. These are all pairs of verbs in their arguments. The female corpus has close gap, make sense, what to do, take time, spend money. So on the left are people actually involved in financial affairs, and on the right are women either looking to be paid as much as men, deciding what to do, making money, spending money. So basically being consumers and employees in the economy, right? And all of this is done using kind of classic rationalistic NLP frameworks. Did those frameworks use transformers? Of course they did. The top of the line dependency parsers all use transformers. I'm not trying to convince anybody not to use transformers. I'm trying to say that to solve this task, the downstream task itself of understanding gender bias, it's unfeasible in this scenario to use ETE, use a huge corpus to learn labels, and then only use a transformer. So we need this fundamental annotation. If you did actually narrowly annotate for specific downstreams to ETE task approaches, things would become First of all, it would be expensive. I hope I don't need to convince anybody attending this event from industry that it's expensive to commission a huge annotation project for a downstream task, especially if you can get a reasonable result by using out-of-the-box NLP. Also, once you've invested all of that money in annotating the narrowly labeled dataset, what becomes of the dataset when it becomes out of date? You can have a great tailor-made dataset for dealing with the 2016 elections, but what happens in the 2020 elections? You can have a great data set for marketing flip phones, but then flip phones are not a thing anymore and the data set becomes useless. What doesn't change so rapidly is noun phrases and entity mentions and relationships between words and argument structure. Those things are fairly stable, and so it's worth investing in NLP infrastructure in developing these things. What happens when you change the language? Great, you made a great marketing data set for whatever downstream commercial application you have, but now you want to support Arabic. Well, if you were using universal dependencies parsers, then hopefully, if you invested in parsing resources and tree banks, you can use a similar parser, outputting similar labels, and use a similar approach. If you use E2E, you now need to label Arabic data. What happens when you add a product? What happens when you add a data source? I already showed you out-of-domain degradation. So we need to be a little bit careful with using E2E approaches and not assume that just because the top-of-the-line papers get the best score on some shuffled test set this way, that this is what we should be doing. I'd like instead to argue that robust domain general NLP should not be brittle. It should provide good solutions out of the box. And you can actually use these to feed state-of-the-art neural approaches. An example of this actually we just did for a shared task on discourse relation extraction, where our lab won the first prize, the best result, by using, of course, text-based transformers, but also feeding them some features from rationalistic NLP to stabilize things in a substantial way. So what do we need? We need multi-layer tree banks. These are data sets that have a lot of different annotations concurrently. I'll explain the concurrently part in a second, because you could theoretically just have one data set that's annotated for syntax trees and another one that's annotated for entities. We need information to build core technologies. These include tokenization, sentence splitting, and for Hebrew, especially morphological segmentation. In case this wasn't clear to anyone here, these are not trivial. You might think sentence splitting is a solved problem. It's not. F scores on sentence splitting are about 92. It's terrible. If you actually apply it to some sort of scraped data, you'll discover sentence splitting errors all over the place because everything is trained on Newswire. We need part of speech tagging. We need dependency parsing. Bonus points if you're doing enhanced dependencies, which give you even more semantic structure, also in a principled and domain general way. We need entity mention and coreference resolution. We need entity linking. We need discourse relation extraction to understand how sentences relate to each other and how documents are built together, because documents are much more sparse than sentences. a lot of the successes of E2E on sentence level annotations cannot be reproduced right now on document level context because of sparseness. We need semantic role labeling, semantic parsing, sentiment analysis, and also for speech, something I'm not talking about today, ASR for speech and PPS, of course. An example of the type of corpus that we're building at Georgetown, where I work, is GUM. Some of you may have run into this corpus as part of the Universal Dependencies project. And it's a very, very richly annotated corpus. If anybody has questions about it, I'm happy to answer them online or offline later. It's a corpus that focuses on the idea of covering very many genres. It doesn't have a ton of data for any of these genres. It currently has 180,000 tokens, but it covers 12 genres, including both text and speech. The idea behind this is to not have enough data in any genre to memorize it, but to have enough genres that nothing is out of domain. Basically, if you're broad enough in what you annotate, eventually you'll be much more resistant to out-of-domain effects because there just won't be that many domains you haven't covered. The corpus includes syntax trees, including enhanced dependencies, information structure, part of speech tagging, of course, entities, non-named entities, entity linking, reference resolution, discourse parsers, speaker attribution, normalized time expressions, a lot of other things. And the idea is to basically say everything that there is to be said about a text so that we can understand what's happening in a rationalistic perspective. And this corpus is actually created entirely by students in Georgetown as part of our computational linguistics curriculum. To illustrate why we're so interested in having a lot of genres, this is a nice paper that I did with a student of mine, Shabnam Behzad, on tagging robustly Reddit data without having Reddit data to train on. And we discovered that if you train on multiple genres, your result is much more robust. And if you train on enough genres, it becomes almost not important to add actual data from Reddit to get part of speech tagging results that are accurate. The more genres you add, and especially if you work with ensembling, the more robust and stable your result can become. Why do you need a lot of layers of annotation for the same data set? Because especially for phenomena above the sentence level, such as pronoun resolution or understanding discourse structure, there's simply not enough examples of the phenomenon that you're looking at to learn just from words. And we were actually able to show in a paper in 2020 that if you want to automatically annotate things for document structure, you can combine knowledge from a variety of information layers. For example, using your predicted pronoun resolution to help you with discourse parsing, or using syntactic parses and using document structure, and using, we used even XML structure of the documents, looking at where paragraphs are, where headings are, to get improvements on tasks that are normally handled just by throwing text at them. Well, guess what? It matters. If you're inside a heading right now, the part of speech probabilities and the syntax parse probabilities change totally. Can you know that something is inside a heading? You can if you maintain multiple layers of information and look at things like HTML tags. The goal of this project was to create a large-scale multi-layered data set that looks a bit like our GUM corpus, which I presented just now. And this data set is called Amalgam. You can check it out on GitHub and you can download it for free. It's 4 million tokens in English, currently covering 8 genres, with an attempt to be as accurate as possible using every dirty trick in the NLP toolkit, from multi-layer annotation to ensembling to asking 5 models trained on different data sets what they think about that, and then mapping the result to what happens to be true on a dev set of this data set. This is actual automatic entity resolution and coreference resolution results from the corpus. What you're seeing here, which happens to be an article about Israeli politics. And you can see that then Prime Minister Benjamin Netanyahu is being recognized correctly as he. If you look closely, you'll also find some errors, but this is the best that we've been able to achieve. The data set is currently being worked on to improve it using crowdsourcing, and we are trying to scale up so that we have enough data that we can learn how to do things above the sentence level more reliably. This is a discourse parser in the same corpus. I don't know how many of you have seen discourse parsers before, but they basically tell you about the relationship between sentences. If you look at it, you can see that you can recognize the most important sentence in the text, which is number 4, because everything points to it, either directly or indirectly. And then there are all sorts of useful relations, such as attribution in number 3, telling you who said the content in number 4. So how do you know that number 4 happened? Because there's attribution in number 3. This is interested in for things like speaker attribution, for even what Rao and Taboada did for gender attribution, for example, of quotations, but for a lot of other purposes as well. So if you had all of this, what could you do with it? I'll let you use your imagination a little bit, kind of feel a little bit greedy and think for a second what you would be able to do if you had gold standard annotations for all of these levels of information. If you have a discourse parse, many of you probably haven't worked with discourse parses before, but you could arbitrarily select some text and get the most important sentence in it. Because discourse parses like this are recursive, which means that if you put a circle around any part of the text, you can find the most important part of that locally. I'm not talking about finding the central discourse unit by training on automatic summarization and telling it for the entire text. I'm saying you could let the user select some arbitrary text in their browser and be told what's the most important sentence in the selection that you just made. You could find all mentions of an entity. If you're doing Wikification, you could even do it cross-document. Imagine if you could auto-link all documents in a collection to their Wikipedia entries. You would have back and forward search, allowing you to elucidate things using Wikipedia, or backwards find all mentions of some concept in Wikipedia in all of your articles. Or imagine if you had discourse relation labels like the ones I just showed you. There's a discourse relation in many data sets for concessions. Would you like to find all the places where a politician concedes a counterpoint to their argument in all of their assembled political speeches from all of the years that you can't possibly read by hand? It would be kind of nice, wouldn't it? Here's at the bottom left some discourse parsing examples for concessions. This period of change may last for some time, concession. The events in the Arab world notwithstanding, oh really, are those a problem for what you're saying? So these look quite different on the surface, right? It's difficult to learn this, but actually concession is a fairly universal relation in language data. If you do this cross-genre, you could get robust results in ways that would generalize beyond studying direct label correspondences of whether something is now pro some political thing in a very narrow sense that won't generalize to next year versus something very, very general that will serve you. And of course, you can use these things as features for multitask learning, for downstream tasks, and so on. All right, last word, how does this apply to Hebrew? For the longest time, all we've had for Hebrew is the Hebrew tree bank, which is very useful for standard language morphosyntax as it appears in the news, but it's 30 years old. It also doesn't know about Google and smartphones and social media. It's also speckled with errors. Anybody who's closely worked with the Hebrew tree bank will know that there are, numbers spelled backwards and weird tokens and errors and all sorts of inconsistencies. And even if it were consistent, it's single domain. It's just news. And it's not huge. It's only 6,000 sentences. So all of this is the starting point and the motivation for what is happening in IAHLT right now. We want to make an order of magnitude more data available with the finest grained detailed, most detailed annotations that we can have. I don't have time to talk about this and I won't talk about this, but I'll let other members talk about it and hope that this has given you an appetite. So to conclude, E2E is very, very impressive right now for narrowly fitting a data set. The caricature at the right, though, is still true out of domain. I'm trying to remember who sent me this. I think it might have been Nathan Schneider. So thanks to him for this one. I'll let you enjoy that one. We need representations that know who did what to whom at a syntactic and semantic level, that understand when and where something happened, maybe also why and what's the main point, in a domain general way that can be harnessed for downstream applications without having to tailor things for every possible downstream application that you don't have the resources to annotate for, and that if you did annotate would become irrelevant in a few months. We want things to be robust and cross-domain. And so we can't, and actually shouldn't, always rely on labeling ad hoc for E2E. And that's what the data in IAHLT is for. All right, thanks. If there are any questions or time to answer questions, I'll answer them. Otherwise, I'll let the next person talk.
Thanks a lot, Amir. Anyone want to ask anything? You can also speak Hebrew or Arabic or French or Japanese. It's Amir, so German. Okay, maybe we'll have.
But just as a comment, everyone that wants to send the question can also use our email, the info@iahlt.org.
Yeah, you can also post it here. Yeah.
Yeah, or post it here or send an email and we will come back to you.
Right. Okay, so Amir, thank you so much for this fascinating talk. I'm convinced. Yeah. Okay. So. And okay, so we started a bit late the first year, and we actually didn't have a whole year to achieve the goal of 10,000 annotated sentences. We had a lot of challenges. I actually wanted to shift the attention a bit to how you can manage it during such times, but I will focus more on the professional level, which maybe Corona will be relevant soon. So yeah. The overview of the talk is as follows. So Amir talked about the historical tree bank, and I am going to lead to that through first presenting very briefly. I know I'm assuming that most people here know what universal dependency are, but what I've seen in recent years, because I also work in the industry and I also do academic stuff, is that many companies will repeat the same tasks, actually. So if you look at morphology or named entity recognition, people who compete with each other, they kind of repeat, they do stuff from scratch, and if not from scratch, they use some open source resources, and then they have to augment them. And I think this is a classical case where people who compete with each other would actually want, in the interest of money and time and other stuff, to share resources in this sense. And I will talk then about the Hebrew tree bank and how we use this smartly. So I will actually talk about 4 cycles. And by cycle, I mean that there is kind of a pendulum that goes from one place to another. There is data and there is your model of the data, and all the time you have to move between the two without getting dizzy and still making a progress, but still remaining consistent, relevant, updated, etc. And this percolates in the first how to use the heritage itself, which we did use, how we use metadata for to look at data, actually. So not only metadata in the classical sense. We built a model, a linguistic model of how to describe the language, but obviously it's like laying a map of some territory you didn't visit yet. And then the more examples you see, suddenly you realize your map is not good enough. So you have to go back. And how do you do this cycle? And how do you then retroactively and retrospectively correct your data? That's partly going to be answered here too. And then I'm going to talk about data integrity. So I'm going to show you some hacks, maybe we'll call them, to check how consistent our data is. And then with some, we're going to look ahead towards the next year and what our plans are. So when you want to be retrospective, you have what's called the Centipedes Dilemma, right? That's the kind of this guy who has many, many legs. I took 5 minutes to try to translate this very famous poem, and then the idea is that this very nice toad is kind of asking the centipede, you know, which leg do you move first, this one or this one? And this guy gets so much into doubts that you can see it can't work anymore. And this is very relevant to each of our cycles, because what we are doing is we actually ask ourselves what we are doing. And we don't want to be too much with this look on ourselves. So how do you do that? Okay, so we first want to use the universal dependencies. We didn't want to, sorry, I'm kind of ahead of myself. So the universal the advantages of universal dependencies. So first of all, there is a universal representation for any human language with some compromises, but it's a unified approach that has been working for over 100 languages so far. There is a relatively small tag set for parts of speech and syntactic relations, which means that you don't need as many examples to start to get some good results. So any of you knows the Tree Bank, which has like so many categories for part of speech, know that how hard it is to classify across 40, 50 tags, while in the universal dependencies tree bank, I think we have around 17. It depends who you ask. For this, there is a large community for universal dependencies, and they developed tools for annotation, for validation, for training parsers. and to some extent they are work cross-language. And the challenges that we are having for Hebrew and this year for Arabic is that the existing tree bank is noisy and not updated, as Amir indicated. UD is not taught in linguistics department, so any linguists who join our team have to be converted to the new church, right? So you have in Tel Aviv and partly in Bar Ilan some generative approaches to language, and in some other universities. And then you have the structural linguistics in Jerusalem mostly, but was partly in Haifa. And then you have the Hebrew philologists. I don't know how else to label this. And we need to convert them. From our experience, it takes around a month. And it's part of our process of onboarding people. Tools have to be customized partly because it's not just about right to left. There are many funky stuff about Hebrew and special characters and what happens to numbers. Anyone who is acquainted with the Hebrew tree banks knows what I'm talking about. The three main kind of foundations or pillar of UD, it's about how you tokenize the words and how you segment the words themselves. It's maybe a very trivial thing for an analytic language like English, but for Hebrew and Arabic, it's a very tough question. Then there is the morphology. Morphology is licensed, like it has a very large, for Hebrew and Arabic, we have a lot to say about morphology, and in this sense, universal dependencies give us a lot of freedom when it comes to describing the morphology of a language. And as for the syntax, it lies somewhere in between. So you can't take a decision in one of them without actually taking a decision about the other. And you can see it here, it's only 4 words, right? התובע עשה כמתבקש ממנו. So if I try to translate it to 4 words in English, it's the prosecutor did as asked. Okay, let's do it like that. And then you can see that in Hebrew, you have to segment at least 3 different morphemes here. And if you don't, once you do that, each of them has a syntactic role, and each syntactic role needs a part of speech, and each part of speech unit has to be mapped to another. So any decision that you make here, if you're not consistent about it, then it's going to percolate, and then Nick will show you later what happens when we don't validate data and how we can actually force linguists to validate. The history of the Hebrew tree bank, there is a very annoying artifact that I see the Zoom is hiding part of the slide, so I hope it's not for you. Okay, so it started with Khalil Sim'an, who is here from Haifa. I'm very proud of this. Started the work at the Technion back in 2001. And then it underwent some changes over here. It's, of course, phrase structure, as you can see, all this recursion here, and it's going on and on. I think the part of speech tagger I'm most acquainted with is many others' dissertation from 2007, which was wonderful work. And then Yoav Goldberg and later Reut Sarfati started to actually convert. We talked about converting linguists, but they converted the tree bank into UD, and with a lot of ad hoc rules, I believe, as reported in their papers. And I think the first full-fledged dependency relation model for Hebrew was in Reut Sarfati 2013, and then with the shared paper with Yoav. And what we've been doing, like in the last year, is that first of all, the UD as it's released now on GitHub is not represented on a document level, and that's not very good for someone who wants to do named entity recognition and other stuff that Amir talked about when they have to do with a document representation, not just a sentence level representation. We want to make it 2.8 going 2.9 compliant. It is. We account for what we do linguistically, so we have over 100 pages of guidelines on how to do UD for Hebrew, and it's written in English, and all of you are very welcome to have a look. We did some human curation on the historical tree bank, and then we extend it with new data, which we sample better, I believe. So the first cycle, which was mostly done by Amir, it was the data, as said, is anachronistic. There was not much design in sampling it. Amir said it's only news, but it's not only that, it is some kind of orientation politically. So certain named entities are very high up there because the selection of the texts. And all the authors had to say about it is that this text was chosen because it represents a fairly standard example of modern Hebrew. So no metrics, we don't actually know how they selected it. So we first developed a linguistic model. It means that Amir practically drafted like 20 pages of how to do that and gave us some gold standard of, let's say, 40 trees of how to model, how to do ourselves. Then we looked at the historical tree bank, and we, again, with lots of little rules, we found lots of inconsistencies. I'll show you later how. We did some curation over that. Then there were these gold examples. Then we checked them with some rules, and we fixed everything. Then we train a neural parser, of course, and we parse unseen data. Humans correct it. We evaluate the parser. And that leads to a lot of trouble you'll see in the third cycle, because we have to refine the model because it's not complete. It's not exhausted because it hasn't seen so many examples, and they were not very well sampled. So the second cycle has to do with the metadata, and that's where the toad is asking the centipede, okay, הקרפדה שואלת את המרבה רגליים. In Arabic, I think it's 44. In French, I think it's 1,000. But okay, we are English, so it has only 100 centipede. So how do you do that? And we have here classical metadata fields. Some of them are for our own sake. We don't share them. It's timestamp, name of annotator, where we keep the duplicates, etc. The others we will release. So which document, where in the document, etc. And then we have kind of freedom. You can click on this button, and we have all kinds of fields where linguists can reflect on what they're doing and share with us certain problems to the extent that it doesn't impede their speed. So that's the dilemma that I presented in the beginning. We don't want to overdo it, and yet many times we don't want linguists just to go ahead and we measure and how fast they are when our data is not integrated, because that's going to fail the modeling, right? And then we use this feedback and we do some data processing. We improve the annotation tools. We change the scheme. So here are a few examples, real life examples. So here is a linguist saying to us in this kind of line in the document, sentence is, first of all, a list of achievements, not an actual sentence, only first one was scraped. So you can see this, מגורים הולמים לעובד זר, and here you have items, right? Do I parse that? So universal dependencies do accommodate this kind of structure. We're not doing it as yet, but this kind of comment is kept, and we have to adopt a policy about it. Here is another one. So after a name appears, says the annotator, I have this prep here, which is not actually part of the article text and is more meta at that. Okay, so here it was Benjamin Netanyahu. And here is a typical Wikipedia thing. If you want to listen to how you pronounce this name, you click here, and if you need help, and if you need more information, and then you say he was born in 21 October, I guess, so October 21. Some people, so the other curation was we edit it and we keep it for annotation. We just send it back to the loop. We don't want to slow down anything. But then we say, okay, but we need a long-term solution. One of them is to improve the Wikipedia harvesting code, so it knows how to skip such areas. And the other is to actually say that this is part of the sentence, because when you deal with data coming from the web, you are going to find such parenthetical comments, and you may want to learn how they relate to the sentence. So this is an open question. I am not going to answer it now, but there is a lot of food for thought in the hundreds of comments we get. There is another comment that the linguist says that here it contains meta-like info. And it's the same entry on Netanyahu, and it says Hatchum HaMedini, and then there is a section. Now, Hatchum HaMedini is a subtitle that appears hundreds of times in Wikipedia. So it depends, again, on your sampling. What we are doing for the long run, we want to check how much it repeats in our data, because you don't want to overfeed your model with too many similar, let alone same sentences, right? So we may want to skip them or not represent them when we train a model. Shortened decision, let's keep it. Okay, move on. And here is another one. Here there was a problem. So this is about, I believe, Israel Uman, who was born to Shlomo Zygmunt these years, and to Miriam. There is another range of years. This is where RTL didn't help. And actually, that was a very nasty bug that took us several weeks, us to Nick, and is a very fast coder to learn how to deal with it. And again, anyone acquainted with the Hebrew tree bank knows that there are problems like that in the Hebrew tree bank. Because when you write numbers in Hebrew, sometimes you shift to English, and what you have is a local LTR, then you move to RTL with the hyphen, then you're again to etc., etc. You understand what I'm talking about. So that's the second. And now the third cycle, I will let a linguist, the examples were given by Ilah Merav. She will present quite painful lesson on linguistics. What I want you to pay attention, if you are not acquainted with all the concepts, is just to see that we have a very similar, morphologically, similar structure. So we have mitbakesh and ra'ui, and I can't see it here on my screen, so mitbakesh again. And it depends, as I said, about how you segment it, and that leads to different decisions. And that leads also to another set of decisions about how to represent it syntactically. So, Hila, can you?
Yes. Good evening. Now I'm going to relate to these two slides. This is an example of a process in which we have a scheme that describes properly a linguistic phenomenon, but after some time we face more challenging syntactic structures that make the former analysis irrelevant or not ideal, and that forces us to change it. So this example may include some technical linguistic details, so I'm sorry about that. But in general, parts of speech correlate with syntactic relations. Usually nouns and sometimes also adjectives like ra'ui are governed through nominal relations. Nominal subject, object, oblique, while verbs are normally heads of clauses. So they are usually governed through clausal relations, such as root, adverbial clause, clausal complement, etc. So in this case, we have two kinds of participles governed through the oblique relations, which is nominal, the oblique relation, which is the nominal relation. But while we tag ra'ui as an adjective, mitbakesh tagged verb as in התובע עשה כפי שמתבקש ממנו. So our first strategy was changing the relation to clausal relation, adverbial clause, as you can see in tree number 2. Can we move to the next slide? Yes, so, but then in the next stage, we found other environments that doesn't allow clausal relations. For example, לתאר את שמתרחש בבית החינוך במכללת אורנים. This clause, this verb, מתרחש, is clearly governed through direct object, and there is no other syntactic relation that could explain it. On the other hand, some environments don't allow denominalization of these verbs, meaning that we can't simply tag them noun or adjective. מתרחש, we prefer not to tag it adjective or noun, because we have also inflected verbs in this environment. Sometimes they inflect morphologically in tense, number, and person, נשיג את כל שנבקש. And sometimes they are transitive and govern direct objects. כל המציל את הנפש האחת. You can say if nefesh is definite. So they are governed through nominal relation, in this case, nominal subject. But at the same time, they govern dependence that only verbs can govern, such as direct objects. So this is only one example of many others, and this is an inherent part of our work. There are things impossible to predict, so we constantly update our scheme to the pace of new phenomena. Thank you.
Thank you so much, Ida. And I think you understand that, even if you didn't understand everything that Ila said, that once we reach a conclusion with enough data, it can be said with some confidence it's a solved problem, then we just need to go back and fix. So that's part of the pipeline. That's why initializing such project takes time, but then we speed up. I get back to these three pillars. So I think you could see in the examples by Ila that any decision about the tokenization and segmentation, right? And any decision about the morphology. So what's this guy, mitbakesh? Is it a verb? Is it an adjective? It's going to affect the way we are going to talk about it syntactically and vice versa. So if Ila talked here about the fact that this is actually an object, then we have other choices for how to represent that. Normally in object position, object relation, we want to have a noun to be consistent with the universal dependency policy. So this is the kind of dilemmas we are having daily. Most of the time people just annotate, so don't get wrong that it's a bunch of linguists arguing all the time, but it's part of the initialization of the process. And I'm moving to the last cycle about data integrity. I'll keep it very short. It's just an example again, and under the hood there are many more. So there are something in UD called fixed expression, and all of us know it as something called multi-word expression, with the classical paper by Sagan and his colleagues. Multi-word expressions, something like a pain in the neck for NLP or something like that. And you can see this is from the historical tree bank, which we have to deal with. We changed it, part of it. So for example, shachmat is fixed in UD according to the Hebrew tree bank, but sheshbesh is not. And there are some other inconsistencies like that you can find. So what we did is that we did it over their data, but we are doing it over our data, is that we are looking for all the fixed expressions and we collect all these guys. And then we are looking for these guys, all these multi-word expressions, and we look for examples where they were annotated not as fixed expressions, right? So here you have another representation of bechol zot, having said that, right? It's also three words. And here it's with a case marker, makes sense, that's another position, and this is a determiner, and this is a pronoun, makes sense, but it's not consistent. So we have to look back again, and we have to check that all these phrases are indeed tagged like that. And this is just one item in the relation, right? It's only fixed, and we are having others. We don't have to do it for all of these. So for some, it makes a lot of sense, like for adpositions. But this is part of the routine we're doing for data integrity. And the model does improve, and that makes linguists happy. So once they see a well-parsed sentence, they say, I didn't have to correct much, that makes everyone happy, I think. Let's look ahead. And so what we wish for the new year, and what we plan, and what we are actually doing. So I've never said we are already 5K sentences ahead. So we have new sentences annotated for morphology and dependency, and we want to reach 20K more. So we are going to have 30,000 by the end of the year. We are starting the named entity recognition. This is a modest estimation. So far, it depends on the granularity. We are going to annotate the named entities. We are still kind of finalizing the guidelines, and then we are going to send a poll to all the fee-paying members of the of IAHLT to tell us whether they are interested exactly in these named entities. So person, location, etc. Everyone is interested, but there are some others which some people want time expressions with high resolution, and some say it's enough for me. It's going to be a time expression. I don't care if it's a recurring event, for example. We are going to extend our Hebrew-Arabic parallel corpus, which Yousef curated and is going to talk about in a minute. For now, we have 200,000 sentences of parallel data between Hebrew and Arabic, and we are compiling a much larger corpus of English-Arabic from one of the bodies that provided us content. For Arabic, we start with, again, as we did for Hebrew, a bit more modest, because if you do some error in the angle of your orientation, you don't want to find yourself 15 miles ahead in the wrong direction. So we keep it a bit more modest for the first year. We are going to annotate 5,000 sentences for morphology and dependencies, and 10,000 for named entities. And we have the other task where we want to deal with Arabic dialects as spoken in the in this area. So for example, in Haifa or in Jerusalem or in parts of Israel where there are different dialects, and we are going to do it by transcribing oral data as well as collecting data from the web, where it can be said that it's semi-spoken. So this kind of hybrid language in Arabic. And we are going to collect more large. We have corpora which have to be processed and turned into data sets. And for unsupervised learning, we're going to actually do the engineering needed to turn them into data sets for training, for example, language models. Thank you so much. So I think Nick is going to talk about the